I'm Bill Moody with Eaton Carter.
And I'm Jeff Griffith with Becker Aviation.
We're going to go through how to disassemble, inspect, and reassemble an Eaton Carter hose-in pressure control valve. This particular pressure control valve is a 47013F-45. This control valve has a flanged end and also a swiveled end. The other type of hose-in control valve we have is a 44646, which has a swivel end on both ends of the hose-in control valve. This particular hose-in control valve also has a flow maximizer device installed. The Flow Max device increases the performance of the hose-in control valve, thereby improving the efficiency of the refueling operation. If you have a hose-in control valve, if you notice the part number is 47013F. F is the designator to indicate that there is a Flow Max device installed inside the hose-in control valve. All of our hose-in control valves, they are direct acting control valves. They react to the back pressure from the aircraft. There is a spring inside the hose-in control valve that is rated to a certain pressure. The -45 indicates these are a 45-pound spring. We have several different models and pressure ratings of springs. We'll get more into the springs during disassembly. So the first thing we want to do is actually remove the main piston. To remove the main piston, we're going to use a piston compression tool. Now there are other devices that you could use to compress the piston. Jeff, in the field, what else would you see to be able to compress the piston?
What you could use in the field is also a C-clamp, and you would get your hose-in control device over to the edge of the bench, clamp it on the underside, and use the clamp down on top.
Okay.
And you would also want to use a little spacer so you wouldn't damage the top of the piston with the C-clamp itself.
Okay, perfect, thank you. So what we're going to do is we're going to install our adapter onto the ribs of the main piston. And then we're going to insert our compression tool. When you insert the compression tool, you want to make sure the hose-in control valve is sitting flush on the tool and it's not at an angle. Next, we're just going to start rotating our adjuster screw. You're going to rotate it just until you feel some resistance. Next, we're going to start screwing the adjuster further in, thereby compressing the piston inside the body. We're going to compress the piston just below the retainer clip. And that should be enough. So now you can see the gap between the piston and retainer clip. Next, we need to remove the retainer clip. To perform this, we need to use either 2 screwdrivers, maybe a hook pick. In this case, I'm just going to use 1 screwdriver and my hand to pull up on the retainer clip. If we look at the retainer clip, you're going to see a small tab. We're going to put our small screwdriver behind that tab and push out away from the body. As we push out, we're going to pull up with our finger and start pulling up on the retainer clip. Now we're just going to walk that retainer clip around the body and it'll start coming out of the cavity. With the retainer clip removed, now we can remove our piston compression tool. Now obviously, as we mentioned, we want to use the proper tools to remove this piston. If you're not using this specific tool or the C-clip that Jeff mentioned, this could cause serious bodily injury. There is a 45-pound spring behind this piston, so without the proper tools, this piston could fly out of the device and cause personal injury. So as the piston starts raising above the body, we're just going to apply a little bit of pressure on the piston just to speed up the process of removing the screw. Once we have that gap, we can then release the piston, remove our adapter, remove our retainer clip, and remove our main piston. We can then remove our piston compression tool. So next thing we're going to need to remove is our spring and our flow maximizer device. Obviously, if you're not using the flow maximizer device, you won't have this in here. But to remove the flow maximizer device, you pull the spring, pull the device from the spring, and then we have our 45-pound spring. Now, Jeff, we mentioned earlier that we do have different ratings of springs. How would we know which spring is in this hose end control valve?
Well, if the nomenclature is rubbed off the side of the body of the hose end control valve, you would have to measure the spring height, because you could have a 35-pound, 45-pound, 48-pound, 50 or 55-pound spring, all in the same housing.
Okay, perfect, thank you. And there is a product bulletin. You can go onto Eaton Carter's webpage. The bulletin will describe in more detail the different lengths of the different springs with the actual dimensions that you can measure the spring. So next we're going to pull our main piston Teflon seal. To do that, we're going to use a pick. And again, at any time we're pulling any seals out of the body, we want to take care not to scratch the inside of the body. There's our Teflon seal. Behind the Teflon seal is going to be a backup O-ring. To remove the seal retainer, we're going to remove 4 Phillips head screws. So we're going to remove the seal retainer from the body, turn it over, remove the screws. You're going to notice on the bottom of the retainer you may find that there is a ball and an O-ring. This is the check ball assembly for the hose end pressure control valve. Now Jeff, what is the purpose of this check valve?
The purpose of the check valve is to relieve the pressure off the backside of the piston when you get done fueling.
Okay, perfect, thank you. All right, so what we're going to do, we're just going to remove the O-ring, the check ball from the seal retainer. Inside the cavity, you're going to see 4 holes, small holes and 1 large hole. In that large hole, you'll find the spring. Remove the spring. Next, we're going to remove the piston seat O-ring. And again, take care not to dig too deep, not to scratch up the inside. With that removed, now we're going to remove our inner piston Teflon seals. To remove these seals, you just want to kind of walk the seals out of that inner cavity. You don't want to pull too hard. As we pull harder, we could scratch the inner cavity. Remove our first Teflon seal. On each Teflon seal, we're going to have a backup O-ring. We want to remove those O-rings. Next, we're going to remove the spacer. The spacer is going to be a little bit tighter fit, so you definitely want to take your time and just kind of walk it out of the cavity as well. Next, we're just going to remove our last Teflon seal and remove the backup O-ring. The last component we're going to remove is our vent. To remove the vent, we're going to use a blockout tool.
Hey Bill, I noticed this vent has a hole in the side of it. Can you put just a normal plug in there?
No, you can't. So as you said, this is a vent. The purpose of this is to vent the inside cavity of the piston while it's in motion. If we blocked off this hole, which is a standard plug, we are not allowing that piston to compress as it should under normal operation. So this vent will actually have a hole through the hex head, and then we'll have a very fine mesh screen in the vent. The screen is there to help protect the inner cavity of the hose end pressure control valve. It prevents any kind of contamination or foreign object debris to enter inside the piston. So at this time, we've completed the disassembly of the hose-in pressure control valve. So now we're going to cover the inspection of the hose-in control valve now that we have it disassembled. So first thing we want to do is inspect the main piston. What we're looking for is any kind of scratches, any gouges in the piston. We kind of want to run our fingernail around. If we feel any kind of scratches where the fingernail digs in, we probably just want to replace the complete piston. What we don't want to do is take an emery cloth and take too much material out of the piston. That would affect the sealing surface during operation.
And what would be the result if we reused a piston that had a little scoring on it, Bill?
Yep. So if we reused it with some scoring, what's going to happen is we're going to start cutting into our Teflon seals. At that time, you're going to have fuel that's going to constantly come out of your vent.
And we don't want constant fuel coming out of the vent.
Absolutely not. We don't want any jet fuel dripping onto the users. Yeah. All right, next thing we want to inspect is our vent. So again, with our vent, we want to make sure that the screen is in place, that there is no debris that you can see through the screen. We also want to turn it over and make sure we can see all the way through the hex. Again, this is a vent. We don't want anything blocking it. Its purpose is to prevent any type of contamination or foreign object debris from entering the hose-in control valve. Next thing we want to inspect is our seal retainer. We want to flip it over and just kind of feel that surface and make sure it's a good smooth surface. We don't have any deep scratches or gouges in that surface.
What would we see in the hose-in control valve that would make us want to rebuild the complete valve as we are today?
Good question. So there's two different scenarios you would see. The first scenario would be during your pressure control valve testing, you would probably see the hose-in control valve controlling too high or acting erratically. That'd give you an indication that we probably need to disassemble and see what's going on. The other indication would be you could have fuel that's constantly coming out your vent. Now the way these hose-in control valves work, it is a normal operation to have some fuel leak out of the vent, but it should be sporadic. It should not be a constant drip or a constant pour. The way these Teflon seals work is they actually wipe away fuel from the piston as it's moving. As it's moving, it's wiping away fuel from the piston into that inner cavity of the hose-in control valve. After time, that fuel is going to leak out just briefly outside the vent, and that is normal. What we don't want to see is during normal operation, fuel just constantly dripping onto the operator. That gives us an indication that we probably have some cut Teflon seals in our hose-in control valve. Yep. The other part of the inspection we want to do is just really the inside cavity of the hose-in control valve. We just kind of want to run our fingers through the cavity and just make sure all of our walls are smooth. We don't feel any nicks, scratches, gouges, and take it all the way down to the inner cavity as well. So we're really trying to inspect where that piston seals inside the cavity. We also want to check our swivels, just to make sure, again, we don't see any scratches or gouges in the swivel area. And that is the inspection of the hose-in control valve. So next we're going to go into the reassembly. But before I reassemble, I kind of want to talk about the hose-in blockout tool. Okay. So this hose-in blockout tool, you'll notice on the front, on the face, we have two hex head holes. That is to remove different sizes of vents in the hose-in control valve. We also have an indicating arrow showing which way we install this device to the hose-in control valve. On the back side, we have a shaft with a spring. The spring is there to help keep this blockout tool in place while we're flowing. We also have a flat edge. That flat edge is what the piston is going to sit on to block that piston from moving. So to install this blockout tool, you'll simply just want to push in the blockout tool and turn it until the nozzle arrow is pointing towards the nozzle. Mm-hmm. Now, Jeff, why would we use a hose-in blockout tool?
A couple reasons, Bill. First one is when you're setting up your pressure controls for your cart or your hydrant truck, and you don't want the hose-in control valve to engage, you want to put the blockout tool in. Another scenario is if you're doing a defuel, and again, you don't want the piston to overreact, causing a unnecessary strain on the truck or the pump. And then the third scenario is when you have to adjust your venturi. You don't want to get any erratic readings, and at that point you would want to utilize the blockout device as well.
Okay, perfect, thank you. All right, so now we're just going to remove the hose-in blockout tool so we can reassemble our hose-in pressure control valve. So the first thing we're going to do is reinstall our piston Teflon seals. To do this, we're going to install our backup O-ring onto our Teflon seals. I always like to use just a very thin film of petroleum lubricant just to help with sliding it into the inner cavity. And we're just going to slide the first Teflon seal into the inner cavity and just push down until it seats on the bottom. Next, we're going to take our spacer and slide it into the inner cavity. And again, the spacer is a tighter fit than the Teflon seals. And we want to slide it all the way down until it's touching that Teflon seal. We're going to take our last Teflon seal, install the backup O-ring, and again apply just a thin film of petroleum lubricant, and slide it into the inner cavity above the spacer. Next thing I want to do is just kind of run my finger through those Teflon seals. Got to help round them out, checking for any nicks, any scratches I may have done during install. Make sure it's a good smooth surface. And now we're going to install our main piston O-ring into the groove that you see right there by the holes. All right, now you'll notice again we have 4 smaller holes and 1 large hole. The large hole is where our check ball assembly is going to be inserted. To do this, first we're going to install our spring into the larger hole using some needle nose pliers. Next, I'm going to take my seal retainer and I'm going to find my 1 offset hole, the smaller hole. I'm going to apply some petroleum lubricant to this to kind of act as a glue. And again, we're just going to use it sparingly. I want to insert the O-ring directly centered over that hole. Apply just a little bit more petroleum lubricant to the top of this O-ring. I'm going to take my check ball and set it right on top of the O-ring. When it's on top, I'm just going to gently push down on the check ball. That's going to help it seat on that O-ring, and that lubricant is going to create like a glue surface to keep this check ball in place. Now, the next thing I want to do is I want to line this check ball up with the spring that's inside the cavity. The alignment is very important. So we're going to gently rotate the seal retainer over. Now, when we install it, we don't want to rotate the seal retainer too much. It could cause that check ball to dislodge. So now my screw holes are lined up, so I'm going to start reinserting my Phillips head screws using my Phillips head screwdriver. So what we're going to do is install our 4 Phillips head screws into the seal retainer. And again, we want to kind of be careful as to not dislodge the check ball. And I just kind of want to get all 4 in there and started before I start tightening them down. Now I'm just going to start tightening them down kind of in the star pattern. And we just want to tighten them down until they're snug. All right, so now that our seal retainer is installed, we want to go back and double check this check ball to make sure it is seated. So we're going to use a small pick and just lightly insert it into that check ball area and slightly push down on the check ball. What we want to feel is that spring, a nice smooth motion, and we release it that the check ball does come back up and seat. So now we know we have a good check ball assembly. So next thing we're going to do is install our main piston Teflon seal and our backup O-ring. We want to install the backup O-ring first into the lower groove. Anytime we're installing these larger Teflon seals, we want to make sure we do it in almost like a heart type shape. We don't want to bend, kink these Teflon seals because that will affect its sealing surface. Now, Jeff, I noticed that there's two different sides of this Teflon seal. Which direction would this go in?
This Teflon seal, we would want the curved edge to go face up.
Okay, correct. And the reason why we do that is this Teflon seal pushes against that piston as it's moving. If it was installed upside down, what would happen is it would not push against that piston, and you'd actually have bypass through that piston. All right, so we're gonna push the Teflon seal back into the same groove of where that O-ring was, being careful not to kink it. You just kind of want to walk that Teflon seal around that groove. And you want to be very careful that while you're walking it around that you're not pushing that backup O-ring out of that groove.
Mm-hmm.
Now that I have the Teflon seal in it, what I want to do is kind of run my finger around that Teflon seal and just make sure it's a smooth surface. I don't have any kinks. And I also don't want to feel that backup O-ring extruding out of that Teflon seal. So next thing we want to do is just simply install our spring. So next we're going to install the Flomax device. The Flomax device is going to be installed with the flat side up. We're just going to slide it right into the spring. Once that's installed, we're going to slide our main piston over the spring. We're going to set a retainer clip on top of the piston. And now we're ready to compress our piston back into place. So to do that, we're going to use our piston compression tool, install our adapter on the piston ribs. Set the hose and control valve into the compression tool. And again, make sure that it sits nice and flush.
Mm-hmm.
And we're just going to start turning our adjuster. Once you start feeling a little bit of resistance, now we kind of want to help that piston align inside this cavity. If we don't help the piston align in the cavity, all that's just going to happen is as we slide the piston into that cavity, it could end up cutting your seals. So we're going to continue to compress our piston into the cavity.
How do you know when the piston's far enough down inside the housing?
Okay, so we're going to compress the piston down just below the first groove that you see. That's going to be our retainer clip. All right, so now we are just below the groove. Now we take the bottom side of our retainer clip, kind of separate that tab from the bottom. We're going to insert this tab into that groove that we just went below. We're going to insert one end of the retainer clip and just start walking that retainer clip around the hose and control valve. And as we're doing this, we want to pay particular attention to this outside tab. We don't want this outside tab resting on the outside of the hose and control valve because this could start scratching and scraping our swivel surface. We're just going to continue to walk it until it's all clipped back in place. And we're going to apply a little bit of force to that tab just to make sure that it's completely seated.
Yep.
Once we're confident the retainer clip is completely seated, we can now remove our piston compression tool. The last thing we need to install is our vent. So the vent is just going to screw into the port. And once again, we're going to use our hose-in blockout tool to just snug that vent. And that is the complete reassembly of the hose-in pressure control valve.